Hi, Michelle. Thank you for introducing me and having me here for this event. I am Musa Stephen Onlue, Project Manager and Transformation Lead at Afrinic. And today I will be sharing with you an important tool for IXPs, Internet Exchange Points. And I will focus on one of the features of this tool, that is managing a route server or many route servers with ISP Manager, depending on the size of your internet exchange point. I hope I'm speaking in the right channel and that you can hear me well. Please let me know if I'm audible.
Yes, we can hear you.
We can hear you.
All right. Merci. So this is going to be a very short presentation, and we are going to have a demo on installing a route server using BERT, the BERT daemon. So we are going to introduce by talking about the ISP Manager. What is ISP Manager? What you can expect ISP Manager to do for you. And we are going to deploy an instance of a route server and then add this route server to ISP Manager, and then we'll see how ISP Manager automates the configuration. And we are also going to see all the features that are available in ISP Manager. So we start by, for those who are not familiar to Internet Exchange Point, but I'm quite surprised that you might not know what is an Internet Exchange Point, but let's see what is an Internet Exchange Point. So it's a fabric, mainly a layer 2 switch where service provider operators, network operators meet to peer. The aim here is to make sure to provide a faster link, a faster connectivity to their customers. So today, many countries, obviously all the countries are understanding the value added of an internet exchange point. And Sarah rightly pointed it in her presentation and showed some numbers of internet exchange point in countries. Like in Africa, I think like we have internet exchange points roughly in all the 54 economies. Here in Mauritius, we have one internet exchange point called the Mauritian Internet Exchange Point, where you have many network operators, that's ISPs, banks, universities who come and peer. So to make sure that we reduce the latency of people connecting to the internet. That said, so what is ISP Manager? So ISP Manager is a free open source software platform for ISPs. Yeah, so for ISP, you know, an ISP will have a lot of things that we configure an internet exchange point, like a route server, looking glasses, route collectors, and then we want also to make our peers maybe apply some good practices like RPKI, IRDB filtering, and things like that. So if you want to configure all of this in separate units, it becomes a bit tedious. So you need an environment, a platform where you can facilitate, where you can ease the configuration of all these tools. There are many softwares out there, but one of them which has been adopted consistently in many exchange points is called the ISP Manager. And with ISP Manager, you have a lot of these features, like possibility of having APIs that will connect to many systems to pull out configuration and maybe render some other configurations. You can configure things like an IS-112 instance, configure route servers, looking glasses, route collectors, and even apply things like manners compliance, graphing with tools like MRTG, Smoke Pink, S-Flow, and very more. So if you go to, let's say, the documentation portal, you will have an extensive list of all the features that you can have in ISP Manager. So in ISP Manager, one of the things that you can automatically configure is a route server. So now, why is it important to have automated configurations? First, for two reasons. The first reason is that if you want to do this configuration manually, we tend to make errors sometimes. Meanwhile, if we have something, a tool to automate, it is the errors, the chances for errors are reduced. And also for scalability, if you're having an internet exchange point, let's say with 10 peers, yeah, you can do the configurations manually. But when your internet exchange points start growing to 20, 50, 100 and more, you now need to automate how you onboard participants on your internet exchange point. So for ISP Manager, for instance, when you install ISP Manager, you can configure your internet exchange point in ISP Manager by specifying where are your facilities, where are your switches, your routers, your cabinets, and things like that. And when you configure all of this in ISP Manager has that ability through the API to query those devices. Like if you add a switch in ISP Manager uses SNMP to query that switch and have all the interfaces on the switch, and it can display the interfaces on the switch, the status, if it's up, if it's connected to a peer, and gives you information about, and do also graphing using things like Nagios, MRTG, Smoke Pink, S-Flow, and things like that. So this is ISP Manager. So why am I talking particularly today about one feature that ISP Manager provides us, the route server? So first of all, let's look at how we peer at the internet exchange point. So when peering at the exchange point, we have two ways. We can have bilateral peering, or we can have multilateral peering. So bilateral peering means that every single peer at the internet exchange point will have to peer with all the rest of the other peers. So looking at the graph that we have here, at the left, you have 2, 4, 6, 8 routers. And you see that each router here has to set up how many? 7 connection with other routers. If it is 10, yeah, it's good because you can easily communicate with 9 other peers and get these links up. But when your network starts scaling, when you start having a huge number of peers connecting to your exchange point, you want to make things easy for them to connect at the exchange point. And the way you do this is by providing what we'll call a route server. So a route server is basically either is a piece of software or an appliance that you connect at the internet exchange point, you configure, and every peer at the internet exchange point will now peer with this route server. And the routes that these peers will send to the route server will now like propagate it to the rest of the other peers. So no need to peer with all the exchange point participants. You just peer with the route server, and the route server, since the route server is peering with all the other peers, they will now be able to, you will be able to have the routes of each of these peers. Now the route server you know, when it is propagating the route, it knows that this route, it propagates it in a transparent mode. That is, it is not going to include, the route server is not going to include is ASN on the path. So it's going to be like you are getting this route directly from the peers connecting at the exchange points. Now, if you are wondering how you can deploy ISP Manager in your exchange point, I've provided documentation here. So there are two ways of doing this configuration. Either you can do it through automated scripts. You'll find the automated scripts on the GitHub page of ISP Manager, which I've provided here, or you can do it manually through the documentation on the ISP Manager website. Now, the requirements when you are deploying this, the ISP Manager, is that it runs under a Linux server or a BSD host, and you have all the documentation available on the website, and also YouTube videos available. It runs with a database, a MySQL database, presently MySQL 8, and it uses a web server, either Apache, Nginx, or any other server. It also uses PHP version 8 or more, and so these are the requirements for your installation. So I'm not going to do an installation here. It's quite straightforward if you go on the YouTube channel of INEX. So now, when you've installed your ISP Manager, you can now add stuff like do members configuration, interface configuration, patch panels, users, contacts, and things like that. And then now, for the session of today, what we are going to focus on is how we add a route server, because you need to add a route server to your ISP Manager for the ISP Manager to be able to control that route server. So this is how you add it. You go under routers, and then you specify the information. So the first information here is the handle. This handle is very important for the configuration script. And then you now choose the VLAN. So, you know, for some large ISP, they have presence in like more than one city or more than one building. So this is what we call VLAN here. So you need to specify where this route server is sitting, and then this is how you choose this in the VLAN fee. You need to specify the protocol of the route server is either IPv4 or IPv6, and yeah. So now when you are creating routers, as I specified when you saw the feature, you saw that there are many things that we can do. We can create an AS112 instance. We can create a looking glass. We can create a route collector. We can create a route server. So you will pick one of them. So in this case, we are having a route server. Then you need to specify the name and the short name, the router ID for the BGP session, the peering IP for the BGP session as well, the ASN that you plan to use, the software. So for this, now we have the Bird version 2 that's out, but you also have other route server tools that you could use, like Quagga, OpenBGP, and so on and so forth. And then you need to also specify the version of the software. So for the version of the software, the operating system, OS, and things like that, these are just like test fields, which the ISP Manager developers would pull to provision statistics for research out there. And then now you need to specify the management host. So for my case, you will see that the IP here is the same, but in a real world scenario, your management IP is different from the peering IP. And then now you need to choose the API type. The API type here is used for the looking glass. So, you know, when you install your route server, you can also activate a looking glass so that you make this looking glass like here. I'm going to make the looking glass public so that people out can have access to the looking glass. And the looking glass, you know, is a very important tool because when a peer is having a problem, they can use the looking glass to do proper troubleshooting and maintenance. And then now the API endpoint, you need to specify. When you configure this, is it a quarantine route server or is it going to be a production route server? And also there are some other features below. So this is the interface for adding a a route server to your instance, to your ISP Manager instance. Let me switch screen here to go to a screen where we have this an instance of ISP Manager, and then I'm going to show you this in the real world. Oops. Bear with me when I'm loading my screen, please. So this is an example of ISP Manager instance, which is out there. This is the instance for the MIXP. So here you have all the features, and if I want to add a route server, I will come under routers here. So you can see we have a bunch of them at the exchange point. So I will just click on add. Here I need to specify the handle, which is something very important. So I will just say this is RS demo dash IPv4. The handle is very important because it's going to be used by the script to generate the configurations of this route server. So the protocol is IPv4. Later I can create for IPv6, and the function. So you see, I can have a route collector, a AS112, or a route server. So in this case, we are using a route server. We are just going to call it RS dash demo. I'll use the same name here for the short name. The router ID I need to reconnect to the server. So this is my IP. I'm going to use same IP for both route ID and peering. The ASN, just pick this one. So what's the platform? The platform is going to be Bird version 2. There are some, so for some reason, ISP Manager and Bird are very, very compatible, like in exchanging information. And the software version is going to be 2.0.8. So this information that I'm entering here is just mainly for statistics. So it's not going to change a lot. Management host, I'm going to use the same IPN. The API type, burst side. So burst side is an API which is used to query the route server and populate the looking glass here in the ISP Manager. So management hosts, so normally in real world, this should be different. As I said, API endpoints, I'm going to just use this and RTM, HTTPS, this API. But now this, I need to make sure that this this name here is that it's reachable. It's reachable. That is the DNS can resolve it. So I will also choose the type of looking glass that I want. If I want a public looking glass, if it's just for customers, or so in much of the situation, we use public looking glass because we want also to provide access to external users so that they can view, and if there is maintenance, they can troubleshoot. So is this going to, I'm going to put this just like a quarantine. Are we going to activate a looking glass here? Yep. Is it going to be RPK enable? I will leave this now for the moment, and then later on when I activate, you will see how it changes the configuration of the route server. So do we want to pass through? Yes. Do not include. So this one, we leave it like that. For the templates, we are going to use the standard templates. Then this we can create. Oops, choose the VLAN. I'm just going to put it in this VLAN, but it's not, so it's quarantine as well. So this is our looking glass, that our route server that we just created, RS demo, which is here. And then when you create it, you can like view the configuration. So it's going to automatically generate configuration for the various peers that you've added here. Now that I've added this route server, let's go on the route server side itself and do the installation of the route server. Bear with me while I connect to my route server. Okay, I am here. So there you go. So what we want to do here is we want to start by installing BERT version 2. I don't have this password of it. Oops, install. All right, so I'm running Ubuntu version 22. So in Ubuntu version 22, it's straightforward. It's in the repository, and yep, now we have it installed, and we need just to go and do the configuration. So the first thing here, which I want to do, is disable the system to start the BERT for me. So I will do that by sudo system control disable BERT. All right, and I also want to stop if there is any instance of BERT running. So what I can do here is to verify. So if I do ps ef grep bird, we can see here that there is no instance of bird running. So what we want to do now is to do the configuration of bird. So I'm going to move to the directory user local sbin. Here we have nothing. So what I'm going to do here is to download the raw file, because there is if you go on the birds repository on GitHub, there are a lot of tools made available by NX to facilitate configuration of all these things. So I am going to go on the website and get the raw file for the configuration tool. So as you do get this raw file. Now we have the raw file here. So I want to rename it to something simple. As you do move API, I'm going to call it just API dash reconfigure. I should reconfigure, and I'm going to give it the name of the handle that we had there, rs-demo-ipv4.sh. Now, if we look at this script, I'm going to use nano to look at the script. Oops. Sudo. Yeah, so pretty much there is not too many things here to change. The only things that we want to change here are the three first lines. That is the API key, all right? The URL for your configuration in the generator on the ISP Manager, and the URL also for updating. So I'm just going to remove this one. These three lines, I can just cut them, and then I'm going to paste mine. Blah, blah, blah. Yeah. There you go. That's all I need here. I want to save this, and I am good to go. So now I need to make this file executable by, as you do chmod a+x dot API. So now I can run this. I can run the script sudo ./API. Oh yeah, a handle is required. So I need to provide the handle. You remember when I was adding the route server to ISP Manager, I had to specify the handle. So the handle was rs-demo-ipv4. Something has gone wrong. User local etc blah blah blah. All right. Okay, yeah. This is because for this instance of route server we haven't added like peering peers to the on the ISP Manager. So if you do ps-ef pipe grep birds, yeah, I need to, let me just switch to an instance that is running, and then I get back on interface. Okay. So here, an instance that is running where we've added like peers is this one. If you go here and you look at generate the configuration that is generated, you will see that everything for all the peers that we add on ISP Manager, we have them added here, and the configuration, that is the BGP configuration, is set up, the filters are applied, and if you do a search here, Control F, and you look for things like IRR, you will see that we've activated IRR filters. All of these are activated on the interface. If you come and you look at, let's say, the configuration here, you will see that so everything that is activated here, it's taken in consideration in the configuration generation file, which is now going to be pushed to the route server. And you can automate, that is the route server, to be picking up this configuration on the, let's say, a specific hour in the day, or like a time frame. You can decide to have the configuration, let's say, twice a day or once a day, so that when you come on the ISP Manager and you, let's say, add you add a peer, when you add a member to your facility, and you tick that this member is going to use the route server, this route server is going to take in consideration this member, and when it's going to be generated, the BGP session is going to be established. So this is what I had to share with you on managing ISP route server with ISP Manager. I will stop here and listen if you have any questions. Thank you.